Alright, hi everyone. You can see we're doing a problem for chapter 7 here, Dozers. This will be the first one in a series for the construction engineering class. So take a moment if you want, pause the video and read this problem. Also, if you want to go ahead and try to solve it and then go ahead and push play, you can follow along or just fast forward to the end for the answer. So you can see the problem here is based on the Caterpillar develop production factors method that is in your book on starting on page 189. So first thing to do when you get this problem, you can see there's a lot of information in here. It's basically a full paragraph. So I'd go through and just underline some of the key things that you're going to have to pull out of here. You can even just write yourself a table. Can be helpful with all the key information that you're going to need as you look through the tables. So yeah, forget that. First thing then that you look through as you go through here is you've got yourself a roller dozer. So it's kind of hidden in there, but it's a good piece of information. Also, universal blade. Keep going as you read. It's a loose stockpile material. That'll come in handy. Here's your distance and your grade that you know you'll need. Average skill. That's a key word that you're going to want to remember. Power shift transmission comes into effect. And here's your type right here. It's a D8. Okay. He shows right here visibility, so make sure you remember to factor that in. Material weight, and remember that's in the bank state. You also have your swell factor, and here's your job efficiency. Here. And then we'll get into the money part at the very end, so we'll go ahead and move on from there. So first thing to do when you have this problem is kind of remember how this works. Basically, you're going to find the ideal maximum production of this piece of equipment based on the Caterpillar charts. So that's given these ideal conditions what its maximum output would be. So you start there, and then we're going to find all the factors that are either going to enhance that ability or degrade it. So, so step one is going to be this ideal maximum production. So for that, information that you're going to want is the type of dozer. So this D8 right here. Keeps asking me that. You're also going to want to know the distance, 250 feet, and you're going to want to know, that's it. So from there, you're going to go ahead and go to this chart, which is 7.14, because we're using a D7 through D11 type. We're going to find our type, which is right here, the D8. N8U, so it's U for universal blade type. So that's curve D. So here's curve D here. Then down here on the x-axis, we're just going to find our average dozing distance, which is 250 feet. So you start at 250, you're going to carry it up to where D is, and I get about 410 right here. So it's kind of a little bit of a judgment call, but it'll be close enough for what we need it for. So then your ideal here is equal to, I said 410, and that, if you look on the y-axis, it tells you it's loose cubic yards per hour. So really the key to a lot of these problems is going to be your units. So you got to make sure that as we go, you're paying attention to loose cubic yards versus bulk cubic yards, and if it's cubic yards or cubic feet, hours, minutes, that kind of thing. So go ahead and alright, so go ahead and pay attention to that while you're going. Alright, so now we've got the ideal. You're going to go ahead and start to pull up the correction factors. So you can go really in almost any order, just as long as you get them all. So make sure that as you go through this, you can look at table 7.2, which is right here. This is table 7.2 on page 192 of your book, so you can go ahead and flip there. You can see all the different correction factors. Yeah, so we want to make sure that we take into account all of these. If you miss one, then you're going to have an issue. So you can start from the top of this chart, or you can start in the order that the book does it. It really doesn't matter as long as you get them all, and it's probably good to be consistent. So pick a method and stick with it. So we'll go ahead and get started. We're going to start just kind of going in the order of the table there. So our second item here is going to be then we'll just do the operator correction. Oops. Pen's acting up a little bit. Yeah, acting up a lot. So the operator correction, you just got to pay attention to what you're looking at. Also in this here, we're using this chart. Make sure that you're looking here at the wheel type tractor. So there's a track type and there's a wheel type column, and a lot of them are the same, but a lot of them are different. So you can see on this very first one, if you were to pick the same as the track type, you get 0.75, but we need to make sure we're paying attention to the problem. It's a wheel type, so it's 0.6. Okay, let's go ahead and kind of mark that for future use. It's going to be a lot neater on your paper, I hope. Okay, and then we're going to move on. One thing that we need to get is we can start talking about materials. So first thing can be a little tricky is this material weight correction factor. So if you remember when we first started talking about this ideal caterpillar, this is not being friendly. They gave us a weight. They gave us a weight of 2,300. So it was the basic standard for this was 2,300 pounds per cubic yard. So we need to compare our soil to the ideal 2,300 and correct for that. So that's not actually on a chart anywhere. That's something that you need to do yourself. So the only kind of trickier part that you need to remember to do. So if you go back up here, we start talking about the material weighs 102 pounds per cubic feet, and that's bank. So we need to use that to get to our material weight. So 2,300, if you remember, was pounds per cubic yard. So we need to transfer this to that unit. So it's kind of a unit conversion here. So we're going to start with 102, and that's pounds per, I'll put foot cubed, and then we're going to convert that into pounds per cubic yard. So you're just going to use the conversion for how many cubic feet are in a cubic yard. So there's 3 feet in a yard. It's a cube, so it's 3 times 3 times 3, or 3 cubed, so it's 27. Okay, that's supposed to be 7. 27, this is cubic feet per 1 cubic yard, or yard cubed. So that'll get us what we need here. Go ahead and calculate that out, punch it in. You should get 2754. And our units, you can see here, are pounds per cubic yard, PCY, right? So that's pounds per cubic yard. Just remember what state this is in. So up here, you go back up here, it says in the bank state. So go ahead and write yourself a little note that that's bank. Okay, so our machines don't push bank. Our machines, our dozers here, when they push, they're going to push loose. So we're going to convert this to loose. And the way that you do that is you use this swell factor right up here. So it's a 12% swell. So you know that when you're going from bank to loose, it's going to decrease in density. So that means that for every cubic yard that you have, it will actually weigh less. So when you're calculating, you can kind of think of it that way, so you don't get confused and multiply by, you know, or increase it or decrease it by 12%. You want it to make sure that your loose is going to be less. So keeping that in mind, we're going to take our bank here, 2754 PCY, and we're going to divide it by 112%, basically. So we're going to get 1.12 on the bottom. That's where that comes from, is that swell factor. And you should punch that in and get 2459. And that's pounds per cubic yard. But that's loose. Okay. All right, so where do we go from there? That's what we want to compare to the ideal state. So the ideal state, if you remember, ideal was 2300 PCY, loose. And our existing is a little bit heavier, it's 2459. So what we do to get this correction factor for the material weight is we take 2300, oops, 2300, and we're going to divide it by our actual 2459. Okay, so you can kind of think of this little equation for the weight correction in the same way that we thought about the swell factor. We know that this is actually heavier per cubic yard than the ideal state, so we should end up with a number less than 1 in this case. If it's lighter, it means it's easier to push, you're going to get a number greater than 1. So just remember that these are all factors that are correcting the ideal. So less than 1 means it's less than ideal, more than 1 means it's greater than ideal or easier, and you're going to get a benefit. So in this case, it's heavier, so we should get a number that is less than 1, and in this case, we get 0.94. So that's probably one of the harder ones. Okay, so then from this point out, it's mostly all just table-based stuff, so we'll continue with the materials. Material here, we're going to do the type now. So material type, correction factor, and here you just go back up to the problem. It said loose stockpile, so loose stockpile, go to your chart. Material, loose stockpile, make sure you're looking at the wheel type, is 1.2, so that's greater than 1. So it's loose material, so it's easier to push, you're going to get a benefit from the ideal state, is basically what's going on here. So you can just go ahead and put from this table that it's 1.2. Alright, so then we move on. We did material weight, we did material type. Go ahead and just keep following this. We can look at the chart. We're not doing slap dozing or side-by-side dozing. So we're sticking with just a standard ideal condition, so that'll be 1.0. So we'll skip those. You can go to the oh, we kind of skipped operator up there. Nope, we didn't. Sorry. We got operator already. We got material. So we're not slot dozing or side by side. Now we can take into account visibility. So looking in the job problem, it says it's going to be poor visibility. So we're going to look at our chart. Visibility, poor, so we're going to adjust for it and make sure we're doing the wheel type. So it's going to be 0.7. So we're going to go visibility was going to be 0.7 because it's poor. 0.7. Okay. So moving on in our chart here, we did visibility. We can do job efficiency now, which job efficiency says in the problem that it's a 50-minute. So we look at 50-minute for a wheel type, and it's 0.83. So I'll put efficiency, and that is 0.83. Okay, so we looked at efficiency. Now we're just going to take into account the grade. Alright, so going back to our chart here, you can see grade is at the bottom. It says C graph. So we're going to look at this graph, and if you look at the graph, look at the problem, it said it's down an 8% grade. So look, make sure you look here. Minus is downhill, plus is uphill, so we're minus 8%. So we go from about here, come up to the line, and that's just about 1.2, which makes sense. We're going downhill, that's better than ideal. 1.2 is greater than 1, so we get a benefit out of it. So 1.2. Alright, so there's grade, and that's pretty much everything. So just make sure you should go back if you kind of skip around. Make sure you go through the whole chart, go through all the steps, and make sure that you've got everything before you move on to the next step here. So the next step is actually to find the production factor. So we're going to take all of these that we calculated, put them together into one number. So alright, so go ahead and gather all these up. You get 0.6 from up at the number 2. You get times 0.94 times 1.2 times 0.7 times 0.83 times 1.2. And I left out all the ones. You can put all the ones. I think the book does go through and say, you know, times 1 times 1 times 1 if it is the ideal. You can go ahead and do that if you want. Otherwise, yeah, otherwise you'll be fine just putting those numbers. Yeah, okay. So we're going to go ahead and calculate that out. Let me actually punch this in. You get 0.6 times 0.94 times 1.2 times 0.7, 0.83, oops, times 1.2. Yeah, 0.47. 472. 0.472. Alright, so there's our production factor. So that's basically telling us that we are only getting about 47% of the ideal state. So you can go ahead and put that in there. So our production now is going to be our ideal times this correction factor. So actually this is a correction factor. And so our ideal, you go back to number 1, was 410 LCY per hour, and you're going to multiply it by 0.472, and you get times 410, 193.5 LCY per hour. Okay, so here again, we need to make sure that we are watching our units, because in the end we're going to want to have our answer, if you look at what they're asking us, is per bulk cubic yard. So let's go ahead and change that now. And if you remember, now we're going from loose to bulk. So our production here will be 193.5 loose cubic yards, and we need to use that swell factor again. So 1.12, because it was 12%. So we're going to have a 12% decrease here in our production, because this is how much we are actually moving around loose. But if you remember, bulk is actually going to be smaller. So we're going to get divided by 1.12, 172.7. And that's bulk cubic yards per hour. So there's our production. Okay, so basically that's one half of the problem. Now the second half here, we'll call that number 9. So step 10, we'll get all the cost data figured out. So if you go back up, we talked about the cost. So you can see the owner and operator, 42, base labor rate, workers' comp, EMR, and benefits. So if you remember, our equation for cost here was equal to, let's just do, we're going to have the owner and operator, or owning and operation of the equipment. It's a pretty easy one. That's 42, just given. And then labor. So labor, which we actually have to work out. So our labor or operator is going to be base rate times the workers' comp, which you kind of want to do like a 1 plus the workers' comp here, times EMR, which was the experience modification ratio that's given by your safety record. So it's either going to help or hurt. Then you're going to add the benefits. So if we punch all the numbers in for that, going back up to the problem, the base rate was 26. We're going to multiply that by the workers' comp, in this case was 18%, so, or 1.18. So it's going to, if you were to punch in just 0.18, then that would make the labor rate smaller, and that just doesn't make sense logically. You should know that workers' comp insurance is going to be a cost, so make sure it's 1.18. And then same with the EMR. This company's EMR was 1.1. I think I put that in the problem. If I didn't, here it is. EMR equals 1.1. Yes, I think I did. Yeah, 1.1. So 1.1 is actually a good thing. It means they have a better safety record than most companies. So actually, I'm sorry, they have a worse. It's a bad thing. They have a worse EMR or safety record than most companies. As you can see by it being above 1 makes their cost higher. Alright, so multiply those three together, add our benefits. Random thing comes up. Benefits came out to $15.50. So do all that arithmetic there, and you're going to get $49.25. And you're going to add this number to the 42 and get a total cost per hour equal to $91.25. So that's dollars per hour. So make sure you keep your units going right. So that's important. Alright, so really final step here, step 11, is just to find the answer, which they were looking for the unit cost of earth moving operation in dollars per bulk cubic yard. So now you're just going to take the dollars, which we're going to use here. So we're going to say that I'll just call this unit production equals the total cost over the production. And remember the units of these. This is a dollars per hour, and this was a bank cubic yards per hour. So your hours end up canceling, and you're left with dollars per cubic yard, which is exactly what we want. So we go ahead and do this out. We get $91.25 per hour. And we're going to divide by 172.7, and this is bank cubic yards per hour, and we come out with 0.53 or 53 cents per bulk cubic yard. Actually, I've been using cubic yard, so you just actually had this number up here is so that's our solution there is about 53 cents, which if you look at some of the other example problems, it kind of fits in. The one in the book is 48 cents, and then the one in the class is similar. So there's that. If there's any questions on this, go ahead and let me know by email or through in class. So that's it.